Ecological network analysis, ENA, is a powerful tool used to study the structure and dynamics of complex systems, often applied in ecology to understand food webs and other ecological networks. To apply ENA to determine who can't sit with us, we can think of the social dynamics as a network where individuals are nodes and interactions, such as friendships, alliances, or conflicts, are edges. Here's a step-by-step approach to using ENA for this purpose. Define the network. Nodes. Individuals in the social group. Edges. Relationships between individuals, e.g., friends, enemies, neutral acquaintances. Collect data. Gather information on the relationships between individuals. This could be through surveys, observations, or social media interactions. Quantify the strength of relationships, e.g., close friends, casual acquaintances, enemies. Construct the network. Create a graph where nodes represent individuals and edges represent the relationships. Assign weights to the edges based on the strength of the relationships. Analyze the network. Centrality measures. Identify key individuals using centrality measures such as degree centrality, number of connections, betweenness centrality, bridge between different groups, and closeness centrality, how close an individual is to all others. Community detection. Use algorithms like Louvain or Girvan-Newman to detect communities or cliques within the network. Clique analysis. Identify tightly knit groups of individuals who are all connected to each other. Determine exclusion criteria. Negative relationships. Identify individuals with a high number of negative relationships, enemies, or conflicts. Peripheral individuals. Look for individuals with low centrality scores, indicating they are not well connected within the network. Bridge individuals. Consider individuals who act as bridges between different groups but may not be fully integrated into any single group. Interpret results. Individuals with a high number of negative relationships or low centrality scores are likely candidates for exclusion. Bridge individuals may be excluded if their role is to connect disparate groups rather than being part of a core group. Validate findings. Cross-reference the network analysis results with real-world observations or additional data to ensure accuracy. Consider the context and dynamics of the social group to understand why certain individuals might be excluded. Example scenario. Imagine a high school social network. Nodes, students, A, B, C, D, E, F, G. Edges. Friendships, positive, and conflicts, negative. Data collection. A is friends with B, C, and D. B is friends with A and C. C is friends with A, B, and E. D is friends with A and has a conflict with E. E is friends with C and has a conflict with D. F is friends with G. G is friends with F. Network construction. Create a graph with nodes A, B, C, D, E, F, G. Draw edges based on the relationships, positive and negative. Analysis. Centrality measures. A, B, and C have high degree centrality. Community detection. A, B, C, D, and E form one community. F and G form another. Negative relationships. D and E have conflicts. Determine exclusion. D and E have conflicts, making them potential candidates for exclusion. F and G are peripheral, forming their own small community. Interpretation. D and E might be excluded due to their conflicts. F and G might be excluded because they are not well integrated into the main group.